Okay, hello. So today we are going to go over covariance, correlation, and we're going to do a simple linear regression. Might actually be a short video because this stuff's a little bit simpler than the previous stuff, but we will find out. All right, so let's go ahead and get started. I'm going to go ahead and switch over to my share screens. Share, share screen two. Cool. All right, so what we're going to do, close this, is we want to calculate the correlation between something like price and miles per gallon. All right. Now, there's always, like always, there's a short way and an easier way to do this. The short way is literally just correlation. Equal correlation between this variable and this variable. And this just tells you how the two move. If one goes up, what happens to the other one? And so what this is saying is that if the miles per gallon goes up, then the price will go down. There's an inverse relationship between the two. And you can think of this as an economy versus luxury cars. So this would be the correlation of price and MPG. Now, let's just go ahead and move that up here. And we'll just merge that. Now, the way you actually calculate a correlation by hand kind of gives it away, like what this number is getting at. The correlation is actually equal to the covariance of the two variables divided by the two standard deviations multiplied by each other. So in a way, it's kind of a variance divided by a variance. And the correlations are going to be bounded between -1 and 1. And the reason that's the case is because the highest, if the covariance is just equal to the standard deviation of one variable multiplied by the standard deviation of the other variable, well, it means that ratio is going to end up being 1. And you can flip it if there's a perfect negative correlation. That means perfect negative correlation of, correlation of -1. It kind of just means the flip, except the covariance is exactly negative of the two standard deviations multiplied by one another. All right, so let's just go ahead and calculate this by hand real quick. So we'll do the covariance of the two. Covariance. We'll just do sample. And that's going to be miles per gallon, our price, and miles per gallon. And we get a covariance of -7,996. Right? So we'll do STD price, and then STD MPG. Nope. All right, so equals standard deviation of the price, and then equal to the standard deviation of miles per gallon. And I got the wrong variable there. Standard deviation. There we go. Okay, we then are going to multiply this number times that number. And then we're going to take the covariance and divide it by that product. And as you can see, -4686, -4686, perfect. Just for fun, let's see how identical it is. 886695. Yep, it's identical. All right, so this is the product of the two standard deviations. All right, so now what we want to do is we want to, say, run a linear regression. And the nice thing is about a linear regression is that, well, A, you're kind of assuming there's a linear relationship between the two variables, and it's going to tell you, okay, if I increase one of the variables by 1, what's going to happen to my output. So it's just like a demand and supply function, a demand and supply curve in a way, because remember, like a demand curve maps a quantity demanded to a price and a price to a quantity demanded. Um, this linear regression is going to do the same thing. All right, so to estimate one, what you're going to do, you're going to highlight your two variables of interest, and then you're going to create a scatter plot. There we go. All right, and so what we have here is our price on the x-axis, and our miles per gallon on the y-axis. That's not what we want. So let's flip this. Let's change this, I guess. By making price our y variable and miles per gallon our x. And you get a similar relationship, but it's not quite as clean. Let's go ahead and add in our chart elements. This is MPG, and this right here is going to be price. All right, and so what we see here is, again, we have a nice negative relationship, which makes sense because of this negative correlation. But now what we want to do is we want to fit a line. And the way we're going to fit a line is you're going to do add trend line. It's going to be linear. And we're going to display the equation on the chart. And then we're going to X out. And there we go. Bingo. Make sure I got everything highlighted correctly. Good. We have our linear regression. So let's kind of explain what this is. This right here, y, is actually the price. This right here is equal to the miles per gallon. And so what it's saying is that if I know the miles per gallon, I also know the price. All right, let's go ahead and apply this formula. Let's imagine we have a car that has a miles per gallon of 20 miles per gallon. What would be our expected price? Well, all we have to do is apply this formula up here, and it would be 11253 minus 238.89 times 20. And so the expected price would be $6,475. So this is MPG, and this would be the estimated price. Let's see what happens if miles per gallon goes up by 1 unit. So we get 21 miles per gallon. What do we expect to happen to the price? Well, the price goes from $6,475 to $6,236. In other words, it's a difference of. So the price fell by $238, which just so happens to be the coefficient estimate right here, or that number in front of miles per gallon. This is not an accident. This right here, this number, this red number, tells you what's going to happen to price if your miles per gallon increases by 1 unit. To illustrate, let's try this again. We'll go from 21 to 22. Again, we see the price falls by $238. And we could do this at all points. We'd still get that same 238.89 with a 1 unit increase in miles per gallon. All right. Well, that covers what I wanted to get done now. I'm going to next post a final linear regression video and then one more homework, and then that will be it, I believe. All right. So if you have any questions, don't hesitate to reach out. Okay. Thanks. Bye.